approach, which I don't show code for here, is that you can actually get the actual eye position in either camera space or world space. So that effectively gives you the exact position and orientation of that eye that you're currently rendering with, associated with that virtual camera. And you can use that to integrate into your system. So whichever way makes sense, there are multiple ways to actually pull this information out of zSpace and get it into a format that's useful to your application. Okay, now let's talk about head tracking. So now we have the stereo rendering loop going fine. We're using zSpace stereo data to actually render the stereo images. So how do you enable head tracking? There's a couple steps that we need to actually look at doing. The first one is, because we haven't talked about it yet, is we actually have to enable our tracking system. Now our tracking system is completely orthogonal to the stereo system. You can use one without the other. It's perfectly fine to do that. So in order to initialize the tracking system, it couldn't be any easier. You just create our tracker system object, and it will automatically initialize the tracker system, start the threads in the background, which actually talk to the tracking system, and get everything going that way. Once you've initialized this, and this is usually done once, then you can actually go and start talking to the tracking system. Now, one of the things that you need to do to actually get the data from the tracking system is call capture targets from the tracker system object. And what this does, it effectively caches the most recent information from the tracking system into structures for you to actually use. So you'll usually do capture target once per frame, oftentimes in your render